Mrs. Banky here. In class we've been practicing a lot with naming compounds and writing formulas, and students have become pretty comfortable writing formulas and naming compounds if they're told ahead of time what type of compound it is, and that reminds them what naming strategy or naming system to use. A reminder that if we have ionic compounds, we do not use any prefixes. However, if we have the binary molecular compounds, we do use prefixes. So on the next slide, I'm going to have a list of formulas, and the task is going to be for us to name them. So what I would like you to do at this point is pause this video and try to give it a shot at naming these. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 compounds. Just give it a shot, and I'll be back to you in a little bit. Okay, I'm back. I hope that you spent the time to try naming these. You may have discovered that sometimes you get confused about when to use prefixes and when not to. So I want to remind you that the only time prefixes get used, I'm going to activate my pen here and try. So prefixes only used if you're looking at a formula, there are 2 elements and they're both nonmetals. Again, it looks like a kindergartner's drawing this. So my strategy for you is to go ahead and look at each formula and first identify whether or not there are only 2 elements. So if we're just looking at elements, this one only has 2 elements, this one only has 2 elements, this one has 2 elements, this one has 2 elements, and this one. So most of them here have 2 elements. Okay. The next strategy is to identify which of these 2 elements, or which of these compounds has 2 nonmetals. So a reminder that with an ionic compound, sorry, I had an itchy nose. I'll get that out of my system. With an ionic compound, if a metal is present, like sodium, it's going to be written first always. So even if you have 2 elements, you can just look at the first element, and if it's a nonmetal, then you probably have 2 nonmetals. So if I look at this, phosphorus is definitely a nonmetal, so I'm just going to circle that one because I know that I will use prefixes when I name this. Nitrogen, we have 2 elements here. Nitrogen is also a nonmetal, so this is going to be another one. Here's another compound with 2 elements. Silicon is a metalloid. Frequently it acts as a nonmetal, so that's the way that we're going to treat it in here. So nonmetal. Gallium, there's 2 elements here. Gallium is a metal, so that one doesn't pertain. Cobalt is also a metal, so that is not one. Boron is a nonmetal, so boron is going to use prefixes, and then carbon and oxygen here, we have 2 nonmetals, so there they are there. So with this, in the naming scheme, we just have to use prefixes to indicate how many there are. So here we have 2 phosphoruses and 5 oxygens. So this becomes diphosphorus. There are 5, so pentoxide. Pentaoxide is a bit cumbersome, so if there are 2 vowels that end up next to one another, typically we drop the A. Okay, diphosphorus pentoxide. Remember that the first element remains the same name with the prefix, and the second element ends in IDE. Here we have nitrogen trihydride. One nitrogen. You might be tempted again to say mononitrogen, but if it's the first element, we eliminate mono. So this is nitrogen trihydride. Next one down, we have silicon, one silicon and two oxygens, so silicon dioxide. And with the next one down, we have two borons and four hydrogens. So we're looking at diboron. You say it. Good. Tetrahydride. If it was oxygen, we would just say sorry, I'm fumbling on my own mouth here. Tetroxide, we would drop the A, but tetrahydride. And here we have one carbon and one oxygen, carbon monoxide. After this slide, I am going to try and see if I can change the settings on this pen. I think they're a bit rough right now. So I'm really sorry about my messy writing. Okay, so again, we identified which of these compounds had two elements and which of them only had nonmetals. We circled them. We went ahead and named them using the right prefixes. Now let's attack the rest of them. Not really attack, but let's look at the rest of them. Here we have three elements, and let's just consider that a more complex one right now, as the three elements here is more complex. So let's just look at the simple ones. I'm going to change my pen color. And I will change it to green. I hope that shows up. So this right here, two elements. The first one is gallium and the second one is chlorine. The first element name stays the same. The second element name ends in IDE. So this just becomes gallium chloride. Oh, that's terrible. My goodness, I might have to write in penmanship. This has cobalt in it, and it has bromine. Now, I know that cobalt can have more than one charge. When I work backwards, if these were ions that were forming this compound, it would have been a +2. So this must be cobalt 2. Bromide. And those are the only two ionic compounds with just two elements. So again, first name first, second name, and an IDE. That brings us to these more complicated ones with three or more elements. And I'll change my pen color again with my kindergarten controlled pad here. So looking at this one, I want to remind you with ionic compounds and with all compounds that we've studied so far, there are always two parts. Most of the time, the first part is just the element. So here, I'm sure without a doubt, most of you could tell me that this is sodium and this is iron. So that means you have to figure out what the second part is. So if the first part is sodium, the second part is everything, well, it's not writing for me, everything else. So here the first part is iron, the second part is everything else. So this combination of elements here is 1 carbon and 3 oxygens. If I look on my cheat sheet, I realize that that is carbonate. So the name of this is simply sodium carbonate. Now you may be tempted, because this 2 is here, to say disodium carbonate, but you have to remember that we're only using prefixes if there are two elements and they're both nonmetals. So the name of this becomes, oh goodness, this must be difficult to watch. Sodium carbonate. Wow. That is crazy. Now, with this one, we have iron, and if you look at this combination of elements here, 1 sulfur and 4 oxygens, that is sulfate. So we have iron, sulfate. Now, iron can have more than one charge, so we have to indicate which iron this is. If I look on my cheat sheet, I see that sulfate has a -2 charge. If they're in a 1-to-1 ratio, that means iron must have a +2 charge. So this becomes iron 2 sulfate. Okay, so again, a strategy for approaching a list of formulas is to figure out which of those compounds are going to use the prefixes and which ones are not. My suggestion is to identify the ones that contain 2 elements, both nonmetals, use the prefixes, and then forget about the prefixes. Okay. Okay, I'm back. I did some setting changes on my pen, and I hope that this works a little bit better. Here we have a list of names of compounds. And again, when we're naming or when we're writing formulas for compounds, a good strategy is to identify which of the names involve prefixes. So if we look at this list, I'm just going to choose blue. That's what I used before. I'm going to use blue, and I'm just going to identify which of these have prefixes. So this one has prefixes: dinitrogen trioxide, lithium sulfate, nope. Phosphorus trifluoride, yep. Vanadium oxide, no prefixes. Aluminum hydroxide, nope. Silicon tetrabromide, yep, there's some prefixes. Silver phosphate, no. Zinc nitride, no prefixes. Zinc nitrate, no prefixes. So the ones that have prefixes, I'm just going to look at the name and write the formulas according to what it says. So dinitrogen means that I have 2 nitrogens. Trioxide means 3 oxygens. So dinitrogen trioxide, N2O3. Phosphorus trifluoride. Go ahead and think what you think that formula is going to be. Thinking time. Okay, we have 1 phosphorus and 3 fluorines. So phosphorus trifluoride, P, 1 phosphorus, F3. And down to silicon tetrabromide, we have 1 silicon, we have 4 bromines, so SiBr4. All right, so those are the only 3 compounds in this list that use prefixes. Now what that means is for all of the other ones, we need to get the right formula. You might be tempted just to look at the name and just go ahead and start writing things. I'm going to change the pen color again, and I will change it to red this time. So you might be tempted to say, oh, lithium sulfate, and go like this. Oh, lithium I know is Li, sulfate is SO4, and you might say, I'm so smart, I remembered what sulfate is, but this would be wrong. You have to put a little bit more effort into coming up with the formulas by writing the charges of each of the ions. So there's not a lot of room here above, but lithium has a +1 charge. Sulfate is SO4 with a -2 charge. So when we come up with the formula, we have Li2SO4. Now what draws my attention to this I'm sorry, my ear itches. What draws my attention to this being sulfate and not the element sulfur is because it ends in ate. That ate should be a red flag, ate or ite, that it could possibly be one of those polyatomic ions. And you remember that those are on your cheat sheet, okay? So we have vanadium 5 oxide. Vanadium 5. The formula for vanadium is V. If it says vanadium 5, it's going to have a +5 charge. Okay. Oxide is oxygen, and oxygen always has a -2 charge. You may have that memorized by now. As you go through these again and again, it becomes a little more familiar to you. So using the crossover rule, I know that I need 5 oxygens and 2 vanadiums, so the formula becomes V2O5. Now, if I wrote this down and I said V2O5, the name of this is divanadium pentoxide. And I said, I'm pretty sure that's right. I'm pretty sure the name of this is divanadium pentoxide. You would say, no, Mrs. Banky, that can't possibly be right because vanadium is a metal. And the only time we use prefixes is if you have 2 elements that are non-metals. So this can't possibly be the name, okay? It's just vanadium, and we have to indicate 5 oxide because of that +5 charge, all right? Aluminum hydroxide. Aluminum has a +3 charge. Hydroxide, that ends in "ide." Most of the time, when the second part ends in "ide," it's usually just a regular or just single old element. But here you see hydro and ox. This is one of the few polyatomic ions that do end in IDE, and it's hydroxide OH. Go figure, it's kind of weird that the oxygen is first in the formula and the hydrogen is second, and it's just the opposite in the name. But it has a -1 charge. Now, if aluminum has a +3 charge and this hydroxide has a -1 charge, I'll just go here where I have some name. I need 3 hydroxides. A common mistake is for students to do this. Now, this is not saying that you have 3 hydroxides. We have to put that in a parentheses. Now we have 3 hydroxides. So Al, parentheses OH, and parentheses 3. Silver phosphate. Silver has a it's Ag with a +1 charge. Phosphate. Ooh, again, it ends in 8. Probably one of those polyatomic ions. Looking at my cheat sheet. I see that in the 3rd column there, I see phosphate, and the formula is PO4 with a -3 charge. So using the crossover rule, my formula becomes Ag3 and then PO4. It looks like my pen's getting out of control again. It seemed better for a while. All right. So if it makes you happy to put that in a parentheses, you can. But since there's only one, we don't need to. Okay, zinc nitride. I know that zinc has a +2 charge. Nitride. Ide. If it ends in ide, it's probably just a regular old element. So I'm going to look on my periodic table. I'm going to see that nitrogen has a -3 charge. The formula of zinc nitride is Zn3N2. Now we have zinc nitrate. And zinc nitrate, again, Zn with a +2 charge. Nitrate. If I look on my polyatomic ion chart, I see that nitrate has an NO3. Okay, this is a parentheses here. Nice warm hug. It's a little group with a -1 charge. So using the crossover rule, it means that we're going to need 2 nitrate groups This is where the parentheses are mandatory. Zn, NO3, 2. So zinc nitrate, Zn, NO3, 2. On the next slide, I'm going to show you a combination. Here, I'll just go there. A combination of names and formulas. And I want you to try to really use your thinking and critical thinking skills to determine if this combination is correct or incorrect. So I suggest that you pause this so that you can just keep this remain on the screen and determine whether or not each of these pairs, these pairings are correct or incorrect. So pause. Okay, I'm hoping that you figured it out by now. I'm back. Let's look at the first one. We have, I'm going to activate my pen here. I don't know if I'm going to write, but if I do, I want to write in, it's still red. I like red. All right, so activating the pen. Looking at the first one, we have Na2S. So we see disodium monosulfate. Now remember that prefixes can only be used if the first element is a nonmetal and the second element is a nonmetal. So this one would be incorrect. There are 2 sodiums for sure, and there is only 1 sulfur. But again, since the sodium is a metal, that just becomes sodium sulfide. All right, looking at the next one, we have magnesium here, and then look at the first part is magnesium. The second part is SO4. If I look on my cheat sheet, I see that SO4 is sulfate. So this one happens to be already correct. I'll put a little star next to it. Correct. Yay. Ding, 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 ding. Magnesium sulfate. Okay. Looking at this one, I have N2O5. I'm recognizing that there are 2 elements and they're both nonmetals, so I should expect to see prefixes. Boom. There they are. My prefixes. Let's check out to see if those prefixes are right. Dinitrogen. Yep. 2 nitrogens. Hexoxide. Oh, hex. Hex is the prefix for not 5, but 6. So I'm going to change the name, or maybe I'll just change the formula. It might be easier to do that. So in order for this to be dinitrogen hexoxide, this needs to be a 6. Or I could have changed the name to dinitrogen pentoxide. Okay, looking at the next one, we have a calcium and we have a nitrogen. Now the name says calcium nitrate. All right, nitrate, I look on my polyatomic ion chart, my cheat sheet, because that's where I see those 8s. And it says that nitrate is NO3 with a -1 charge. I don't have NO3 here, I just have N. So for this to be named properly, it is not going to be calcium nitrate, it's going to be calcium nitride. It is easier for me to just cross off the nitrate and write nitride than it would be to try and change this formula to actually be nitrate. Okay, looking at the next one, we have NH4Cl. So we've got more than 3 elements, so it's not going to use prefixes, and yep, I see it's not using prefixes. So there's probably a polyatomic ion in here. Now this first element is not a metal, and I remember that sometimes the first part of an ionic compound is NH4. So NH4 is the only time that we commonly have the first part of a compound being a polyatomic ion. It is ammonium. Since we just have chlorine here, it is chloride. So the name of this would not be nitrogen-hydrogen chloride. That's like 3 parts. It will be ammonium chloride. All right, looking at the next one, I have 3 elements again. The first one's silver, which means that the rest of this is a group. Oh, remember we just set up here that nitrate is NO3. So it's inappropriate to call this silver nitrogen oxide, as tempting as it may be, because NO3 is nitrate. So the right name of this is nitrate, silver nitrate. Okay, potassium oxide. This is potassium, this is oxygen. Okay, potassium is a metal, so we wouldn't use prefixes. Nope, no prefixes there. I just want to double check that this is the right formula for potassium oxide. Potassium has a +1 charge. Oxygen has a -2 charge. When I use the crossover rule, I get K2O, K2O. Yeah. Ding, 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 ding. This one is right, just the way it is. All right, looking at the next one, I have 2 elements. They're both nonmetals. And do I see any prefixes in the name? Oh, I do not. So I can't just go naming this sulfur oxide, because what if I had SO3? Or what if I had S2O4? We can't name them all sulfur oxide, because these are compounds that can exist. I'm going to cross those out because they're extremely messy. So because we have 1 sulfur and 2 oxygens, the prefix for 2 is di, sulfur dioxide. The next one is pretty tricky. We have aluminum, we have oxygen. I see aluminum and oxygen. Aluminum is a metal, so we shouldn't have any prefixes. That's good. Let's just see if the formula for aluminum oxide is right. Aluminum has a +3 charge. Oxygen has a -2 charge. That does not fit what is here. So this is not the correct formula for a compound containing aluminum oxygen. I would have to add a 3 right here. Al2O3 would be the right formula. Okay. There's something else wrong with this. If you look at aluminum on the periodic table, well, first of all, aluminum has a +3 charge here. And you might say, well, this needs to be aluminum 3 oxide then. But if you look on the periodic table, what you will see is the aluminum symbol, and you will see a little 3+. That's kind of messy, I'm sorry. There isn't another ion charge there. So since aluminum can only have 1 charge, we do not need a Roman numeral in the name. All right. So this concludes my lesson on some strategies for when you get compounds that are mixed up and you need to name them appropriately and write the right formulas. And it can be challenging. The more practice you do, the better you'll get at it. Use your resources. You have your cheat sheet, you have your periodic table, and at this point I'm going to let you use that summary flow chart as a reminder to help you get through it. So again, please feel free to contact me if you have any questions. You can send me a message on the NEO Learning Management System. That's the one I'm currently using. If this is a video for future years that I use a little bit later and I'm not using that one, I apologize if you have no idea what it is that I'm talking about. So I hope that you have a great rest of your day, and I wish you the best of luck with becoming better and better at this. Good night. Good day. Whatever time it is for you. Kind of evening for me, so I'll say good night.